This is Janet and Rabia.
Welcome to Everest Physics Academy.
Before we start, we'd like to recommend our Everest Physics books for high school,
where you can find more explanations and solve applications and problems.
This problem is about the curves of energy versus time of damped horizontal elastic pendulum. So in this video, we are going to match each curve to its corresponding energy, determine the pseudo-period, the force constant of the spring, the mass of the block, and its maximum speed, and finally determine the loss in the mechanical energy when the oscillations die out.
consider a horizontal elastic pendulum S. These curves represent the kinetic energy, the elastic potential energy, and the mechanical energy of the S-Earth system as functions of time. At t0 equals 0, x is equal to xm0, which is equal to 10 centimeters, and the block is released from rest. The damping is very slight. Part 1. Match each curve to its corresponding energy. Justify. Let's start with curve A. The mechanical energy is equal to the sum of the kinetic and the elastic potential energies. We know that Ke is equal to 1/2 mv squared, so Ke is a positive quantity. Also, EPE is equal to 1/2 kx squared, so EPE is a positive quantity. Therefore, ME is the sum of two positive quantities. So, ME is greater or equal to Ke, and also ME is greater or equal to EPE. Therefore, curve A represents ME versus time. Let's move to curve B. You know that at t0 equals 0, x is equal to xm0. Now, which one of the two curves, Ke or EPE, is maximum at t0 equals 0? You know that EPE is equal to 1/2 kx squared. So EPE is maximum at t0 equals 0. Therefore, curve B represents EPE versus time.
Now, let's move to the kinetic energy. The block starts from rest at t0 equals 0, so the initial speed of the block is equal to 0, and then the initial kinetic energy of the block is equal to 0. According to curve C, the energy corresponding to this curve is equal to 0 at t0 equals 0. Therefore, curve C represents the kinetic energy of the block versus time. Now, question number 2. Specify the type of the mechanical oscillations. Since the mechanical energy of the system decreases with time and we have no external intervention, therefore the type of oscillation is the free damped mechanical oscillations. 3. Determine the force constant K of the spring. The graph shows that at t0 equal to 0, the elastic potential energy stored in the spring is equal to 6 millijoules. And we know that the initial abscissa or the elongation of the spring at t0 equal to 0 is equal to xm of 0, which is 10 centimeter. So we can use this formula. EPE at t equals 0 equal 1/2 k xm of 0 squared. Then substitute for EPE 0 equals 6 times 10 to the power minus 3 joules, and xm of 0 is equal to 0.1 meter. Therefore, K is equal to 1.2 newtons per meter.
Focus, please. This is important.
Now, let's move to part 4a. Determine the pseudo-period T of oscillation of G. Remember that G is the center of mass of the block of the oscillator. Now, if you examine the figure, you will see that the period of the energy is equal to 1.08 seconds. But we want the pseudo-period of oscillation. We know that T pseudo is equal to 2 times T energy. This formula is discussed in a video in this channel whose title is Curves of Energy versus Abscissa and versus Time of a Simple Harmonic Motion. You can watch it. Now, T energy is equal to 1.08 seconds, and the answer is 2.16 seconds. For B, T is very close to the natural period T0 of the pendulum. Why? And then deduce the value of M. So how can we compare T and T0 if we don't have the value of T0? Actually, in the beginning of the question, we said that the damping is very slight. And when the damping is very slight, the pseudo-period approaches the natural period and they are almost equal. So T is very close to T0. Now to calculate M, we use the formula of the natural period. Remember, these are free damped mechanical oscillations, but because the damping is very slight, so we can use the formula of the natural period. So square both sides. We have T0 squared is equal to 4 pi squared times M over K. And now the natural period or the pseudo period is equal to 2.16 seconds. And the force constant is 1.2 newtons per meters. And the answer is M is equal to 0.14 kilograms.
Question number 5. Determine the maximum speed attained by the block. Curve B shows that the maximum kinetic energy attained by the block is equal to 4.15 millijoules, which is equal to 4.15 times 10 to the power minus 3 joules. But Ke maximum is given by 1/2 mv maximum squared. Then substitute for Ke maximum and m, which is equal to 0.14. So we get the maximum speed attained by the block, which is equal to 0.246 meters per second. Question number 6. Specify the loss in the mechanical energy after a long time. After a long time, all the mechanical energy in the system is converted into thermal due to the presence of the friction force. So after a long time, the mechanical energy becomes equal to 0. So the loss in the mechanical energy equal to the initial mechanical energy, which is 6 times 10 to the power minus 3 joules.
Now, after finishing the problem, we'd like to explain this remark. Recall that when we discussed the curves of energy for an undamped horizontal spring block system, we conclude that when x is equal to plus minus x max, v is 0, which means that when the center of mass of the block is at the extreme positions, its speed is 0. And when v is maximum, x is equal to 0, which means that when the center of mass of the block is at the equilibrium position or at the origin of the x-axis, its speed is maximum. Now, let's see, is this applicable in our case? I mean, the case of a free damped mechanical oscillations? Let's see. So, look at the curve of EPE. When EPE is maximum, KE is 0. Okay? Now, what does this mean? When EPE is maximum, this means that x is equal to plus minus x max. And when KE is 0, means that V is 0. So the first part of the remark is the same for both cases of damped and undamped oscillations. Let's move to the second part of the remark. Observe. When KE is maximum, EPE is not equal to 0. What does this mean? KE is maximum means V is maximum. EPE is different from 0. X is different from 0. So, when the speed of the center of mass of the block is maximum, the center of mass is not at the equilibrium position. So the second part of the remark is not the same in the two cases of damped and undamped oscillations.
Thank you for watching. If you like this video,
subscribe to the channel, hit the like button and share